we finish off today or earlier, we find out what is our shear stress value, which is 158.519 omega L. And then we also discover what is our average stress. So what we are trying to do now, by looking at Mohs circle, we are trying to calculate or determine, okay, we are going to determine our radius R, which is equal to our tau max. Okay, the R I refer over here is this R over here. Okay, and we know that tau max cannot be more than what? 100 megapascal over here. So we already know our stress average is equal to 70.8 omega L squared. And we have determined that our shear XY over here is equal to 158.519 omega L. Okay, so from here, we can determine the radius of our circle by doing very basic math. Math that is so easy that you guys are very good at. So to calculate the radius of the circle, you are going to have tau max will be equal to square root, okay, square root of 70.8 omega L squared again plus by 158.519 omega L and then the whole thing squared. Okay. And then this whole thing will be equal to 100 times 10 to the power 6. From the course evaluation, I was taught that I was doing too much fundamental stuff. So I'm going to skip the fundamental stuff and give you the final answer in this context. Okay, so what you will get over here is 5.011 times by 10 to the power 3 omega squared L to the power 4 plus by 25.128 times 10 to the power 3 omega squared L squared, and this is equal to 10 times 10 to the power of 15. Okay, so this is the form that we get. Can anyone remember what was the objective of this question? By now, you will have forget. So what we want to do is we would like to determine omega and factor of what? Safety, yes or no? Right. Given this equation down here, you realize that we have one equation and we have what? Two what? Unknowns. The unknowns is omega, is what we want to determine, and the other unknown is L. So I will expect you all to do this in the term test and our final exam. What you're going to do is you're going to assume that L is equal to 2 meters. When I say assume, over here means it is up to you. You want to assume it equal to 1 meter? Fine. You want to assume it equal to 3 meters? Go for it. You want to assume it to be 6 meters? Have fun. Are we clear? Because when I grade you, this variable can change. And I know the specific answer. Are we clear? So at any time in your term test, okay, you realize that you did. I have two equations or two unknowns, and I have what? One equation. Okay. So you can assume what? L. Don't you dare assume omega is equal to how many what? 200 what? Newton meter. Are we clear? Why you cannot assume omega equal to 200 Newton meter? Anyone? The objective is to determine what? Omega. Don't you dare come and be smart to me, Eugene. I assume this is equal to 200 meter. This is the statistical. No, I'm not going to entertain that. I will clear. That's why I want to do this for example for you guys. Okay. So you assume that L is, if you want it to be 1 meter, go for it. Have fun. Okay. So when that's the case, now you realize that you can plug in the values. So when you plug in the values, you have 80.176 times 10 to the power 3 omega squared plus by 25, no, plus by 100.512 times 10 to the power 3 omega squared. And this whole thing is equal to 10 times 10 to the power 15. So when that's the case, your omega will be equal to square root of 10 times 10 to the power 15 divided by 180.688 times 10 to the power 3. So this will be equal to 235.253 times 10 to the power 3 Newton meter. Newton per meter, sorry. Okay. So we have determined omega. Next, we have to determine our factor of safety. Okay, we have to determine our factor of safety. To determine our factor of safety, what we want to determine is we want to find at this point what is our stress 1. I repeat again, we want to determine at this point what is stress 1. So what we have done now is we have ensured that the maximum shear stress cannot be more than what? 100 megapascal. When did we do that? We do that when we formulate this equation over here. This equation over here tells us that the diameter of the circle or the radius the radius of the circle cannot go beyond what? 100 megapascal. Now we have to check this point over here and this point over here. And from what we can see, the positive value has to be checked because by this sketch, stress 1 is greater than what? Stress 2. Are we clear? Okay, so now we are going to determine stress 1. Or we are going to determine our stress max. And this stress max over here is our what? Principal what? Stress. Why we determine our principal stress? Because the stress yield is equal to 200 times 10 to the power 6. How do they determine this? This is determined by what? Uni what? Excel. And the value presented here is also the what? Principal stress from where? Experimental, right? Data. Are we clear? So we have to also determine our principal stress because our structure has a combination of what? Our structure, if you look at Mohs circle, our structure has both normal and what? Shearing stress. But at stress 1, what will happen? We only have what? Normal stress. Are we clear? So stress 1 is equal to stress average plus by our tau max. Okay, stress average plus our tau max. So the stress average will be equal to what? So we have calculated our stress average is equal to 70.8. So we have 70.8 times, is it just 70.8? Yep, 70.8. And we have our omega. Let me write down the formula first, okay? So it's equal to 70.8 omega L squared plus, we know that tau max is equal to what? Plus by 100 times 10 to the power 6. Okay, we know that is our tau max. Okay, so this will be equal to 70.8. Oh, you did write properly. Calm down. Come on. 70.8 multiply by 235.253 times 10 to the power 3 multiplied by the length of 2 meters squared plus by 100 times 10 to the power 6. So this will be equal to 70.8235.253 times 2 times 2 is equal to 166.614. Okay, so from here, I'm just going to put the arrow down here to calculate our factor of safety is equal to stress U divided by stress 1, 200 times 10 to the power 6 divided by 166.614 times 10 to the power 6. So 200 divided by 166.614 is equal to 1.2. At the end of this course, you must be capable of doing everything in one question. Are we clear? Okay, so this is the, so you can see the difference with this course and 2P is what? You have a lot of things being what? Integrated, and you have to understand a lot of concept. Are we clear? Okay, and every week I will post about 6 to 7 problems for you. Make sure you complete them. Okay, and your homework grades will be marked on completion. Are we clear? Okay, so try to do them, try to do as much as you can. Okay, right. Topic that we are going to cover is known as centric buckling. Okay, now where does it, so if we go back to the textbook, okay, I'm doing to you guys what I do to you guys in what? In 2Q, same thing. Okay, so if you look at the textbook, if we go down to table of content, have you downloaded the textbook, yes or no? Okay, so you have chapter 1, understand concept of stress, strain, they're too easy for you. What I'm going to start off with, we're going to start off with this known as what? Columns. Can you see columns? Okay, so what I'm going to do today is under columns, chapter 10. Okay, I'm going to start from chapter 10 because chapter 10 is one of the most difficult topics. Very abstract and you have not seen before. Okay, I'm going to start with chapter 10. So in terms of textbook, this refers to chapter 10. Okay. Now, what do we mean by buckling? Okay, do we always need to do structures that need to buckle? And I think I showed this to you guys when I was doing 2P04 or 2Q04. This piece of paper. Who make paper? Not you or me. Who does that? Someone in the physics department, or someone in the science department, or someone in the material science department. Let me make a piece of paper. Paper initially cannot support my wallet. Mechanical engineers, what we tend to do? We tend to fold. I will write for you the formula for buckling. Okay, I'll write the formula down for you. The formula for buckling, if I can find the formula. The formula for buckling, critical load is equal to pi squared EI over L squared. Can someone tell me what's so unique about this formula?